Okay, so this is the video walkthrough for exam 2 for section 80649. If you have the other section, your video will be later on in the stream. Okay, so let's just start. This is Form A. If you have Form B of the exam, it's the same questions, just a different order, but all the same questions. So let's start with the first one here. Multiply these three numbers together. This is a throwback to exam 1, where in multiplication, you count up the sig figs in each here. There's 3 in each. That means your final answer should have 3 as well. So multiplying these things all together, I get 1.575. And then I have to terminate that to 3 significant figures. Okay, which means I have to drop this last digit here, but since it's a 5 or greater, I have to round up. So the answer here on the first one should be C. All right, so this is number 2. Which of the following is a noble gas? This is just straight sort of definitions from the lecture. And the noble gases are that last column or family or group of the periodic table: neon, helium, argon, krypton, xenon, etc. These are not noble gases. None of them are. So the correct answer here is none of the above. The third one, aqueous HClO2, is classified as which of the following? This certainly has a acid type look to it, so it's going to be an acid. It begins with that H, and there's several different elements here. There's 3, so it's ternary, and it's an oxyacid. Number 4, which fourth period transition element has the highest atomic number? Keyword here is transition, so remember you're in that center area of the periodic table. For this, the fourth period down, this would be the elements from scandium to zinc. So zinc has the highest atomic number of those elements. 5, water in a swimming pool has chlorine in it and other dissolved salts. That's a mixture for sure, and more or less the handful of water in the shallow end is the same as the deep end, so that's homogeneous throughout. Number 6 was the chemical formula for tetraphosphorus trisulfide. Memorization of these prefixes tells you there's 4 phosphorus, and tri is 3 sulfurs. Okay, so the correct answer here should be A. 7, the ionic charge on the cobalt ion. The superscripts and subscripts got messed up here, but the 3 here is supposed to be a subscript on cobalt. So we usually make this kind of graph. We know nitrogen is -3. There's 2 of them, so the total there is -6. We know that must be neutralized by the cobalt in this molecule, so +6 total. There's 3 cobalts there, so this should be +2 on each cobalt. All right, so our answer here is A. Number 8, how many orbitals are in the 4s subshell? Every s subshell has exactly 1 orbital, okay? So the answer there is 1. There's 2 electrons in that orbital, okay, but there's only 1 orbital there in that s subshell. Number 9, the maximum number of electrons that can occupy a p energy sublevel. On each p, there's 3 orbitals, each with 2 electrons. So there the answer is 6. 10, what's the term for the atomic model that describes electrons circling the nucleus in an orbit? And that orbit is the key word here. We mostly associated that with the Bohr model of the atom, so our answer here is D. 11, abbreviated notation means it's going to start with a noble gas in brackets. For aluminum, we count backwards, and the previous noble gas is neon. So the correct answer for number 11 has to be C, neon, 3s2, 3p1. 12, this is just a definition from the slides. Isotopes are 2 atoms with the same number of protons, so they're the same element, but they have a different number of neutrons. 13, ionization energy increases. Right, we just memorized these sorts of trends for atomic radii and metallic character and ionization energy. Here, ionization energy increases going from left to right and bottom to top. Right? Precisely because those atoms are getting smaller, it's going to be harder to remove that electron since it's closer to the nucleus. 14, Kind of didn't get formatted here correctly, but you're basically asked for the electron dot formula for boron, which we draw the element symbol, and then start adding a dot for each valence electron. Boron has 3 valence electrons, so we add a dot on each of 3 sides. Don't start pairing them up. This should be the electron dot formula. For this one, I think it wanted B, corresponded to that figure. 15, change a state from liquid to a gas. Okay, vaporization, that looks promising. Condensing is the opposite. Freezing, liquid to solid. Melting, solid to liquid. So from a liquid to a gas has to be vaping or vaporizing. Atomic notation for number 16. We want an element with 26 protons. So we look at the periodic table. That is iron. The atomic number is 26. So we write an iron with a subscript 26 before it. There's 32 neutrons. So the protons plus the neutrons here is 58. That's the mass number that goes up and to the left of the element symbol. Okay, so it's messy there, but this should correspond to option C here. Which of the following properties is a chemical property of kerosene? Keywords are flammable or reactivity for chemical properties. So flammable with oxygen, that's the chemical property that it burns. The rest are physical properties. 18, throwback to exam 1 and unit conversion here, starting with 46.5 cubic centimeters. And we're asked for the volume in cubic inches. So we set this up like we do all unit conversions, writing the units we're after on the right, starting with the units we're given, and then we're going to need a unit factor in here. And we might need more than one. Let's use the unit factor given. Centimeters needs to go on the bottom to cancel with the given centimeters. So I'm going to write 2.54 with centimeters on the bottom. And that corresponds to the top being 1.00 inches. And that centimeter will cancel out one of the centimeters here, but there's 3. This cube means there's 3 centimeter units. So I'm going to need to do that same unit factor 3 times. And so 46.5 divided by 2.54 divided by 2.54 divided by 2.54, you should get something like 2.84 as your answer. Number 19, this is just, you had to learn elements of the periodic table. Manganese is Mn, so 19 should be A. 20, this is the trend, again, smallest atomic radius, okay? Up and to the right, atoms get smaller, so the element here that's furthest up and to the right would be A, oxygen. 21, the formula predicted when silver and oxygen combine. Silver is abbreviated Ag. Oxygen is abbreviated O. We write the charges above them. Oxygen always wants to be 2 minus. Silver is one of those we memorized. It's always +1. So we use the crossover rule here to get Ag to O. 21 should be B. 22, the formula for copper 1 nitrite. Nitrite we look up in our table of polyatomics is NO2. Minus copper 1 means it's copper, say 1 plus charge. Since those are equal 1-to-1 ratios, then our formula here is just CuNO2. 23, the element symbol Pb stands for lead. And 24, another element symbol question, germanium is Ge. Okay, so that does it for exam 1. Section 80649. Sorry, exam 2, section 80649.